In 2017, a tourist from Singapore arrived on Komodo Island and made a decision that would eventually cost him his life. Hoping to explore the terrain on his own terms, he bypassed the local guides and hiked into the island's volcanic hills completely alone. While distracted by his camera, he failed to notice the predator closing in from behind. A Komodo dragon lunged from the brush, sinking its teeth into his leg before he could even turn around. The man managed to escape the immediate attack and was evacuated for medical treatment. However, his survival was temporary. Despite receiving hospital care and medication, he died 2 months later. These predators have spent millions of years refining an anatomy designed for a specific sequence of capture. They're highly efficient hunters that use a multi-stage attack to ensure their prey never truly recovers. To understand how a bite can kill a healthy adult 60 days after the event, we have to closely examine the specific biological tools delivered in the first few seconds of the hunt. This is the primary hunting ground, the dry, brown volcanic hills of the Indonesian islands. The Komodo dragon scales mimic the rough texture and earth tones of this landscape, allowing a half-ton predator to remain invisible in the open. This diagram shows the scale of their tracking ability. By flicking its forked tongue to collect air particles, a dragon can detect the scent of a carcass or a vulnerable animal from 10 kilometers away, effectively turning the entire island into a sensory grid. Once the target is within range, the dragon moves with surprising speed. It can transition from a stationary wait to a sprint of 20 kilometers per hour, closing the final gap before the prey can react. They consistently target large local wildlife. As seen in this photograph, wild deer are a primary food source on the islands, providing enough mass to sustain a large dragon for weeks. The success of the hunt depends on this initial ambush. The dragon doesn't need to win a long-distance chase. It only needs to secure a single physical connection with its target. This extreme close-up reveals the hardware behind that connection. The mouth contains over 60 serrated teeth, shaped like those of a shark, which are designed to grip and tear deep lacerations into the muscle. However, the mechanical damage from the teeth is only a delivery system. The real threat is the fluid introduced into the wound. Their saliva carries a dual-threat payload, a combination of 50 different bacterial strains, and a venom produced in specialized glands in the lower jaw. The venom acts immediately on the prey's physiology. It prevents blood from clotting and causes a rapid drop in blood pressure, sending the animal into a state of shock that prevents it from fighting back effectively. This enables a bite-and-wait strategy. The dragon can release its prey after one strike. While the wounded animal may initially run away, the biological shock and systemic blood loss eventually cause it to collapse miles away. Once the prey falls, the dragon uses its smell to locate the body and begin eating. As this silhouette shows, a dragon can consume up to 80% of its own body weight in a single meal, utilizing almost every part of the carcass. This explains the 2-month delay in the Singaporean tourist's death. While doctors can manage the immediate drop in blood pressure, the introduction of 50 distinct bacterial strains into deep tissue can lead to chronic, systemic infections that overwhelm the body weeks after the initial trauma. These adaptations define the Komodo dragon's existence on land, but its survival strategy is equally refined in the water. This photograph shows their proficiency as swimmers. They are one of the few large reptiles capable of crossing the turquoise channels between islands, allowing them to expand their territory and find new hunting grounds across the archipelago. They also exert control over their environment through burrowing. Females dig several meters into these dirt mounds to create deep, protected nests that insulate their eggs from predators and the fluctuating island temperatures. Their most unique survival mechanism, however, is a biological process called parthenogenesis. This allows a female to produce viable offspring without a male partner. It ensures that even a single female reaching a new island can successfully establish a new population, securing the species' future in total isolation. Despite these advanced traits, they have a localized existence. They live for about 30 years and are found in only 5 specific locations in Indonesia. Within that short lifespan, the Komodo dragon has combined powerful sensory tracking, deadly biological shock, and independent reproduction into a single, self-sustaining design. it remains one of the most effectively engineered predators in the natural world.